So I'm going to record this lesson. Feel free to stop me if you have any questions, and please stop me if I make any mistakes. Let's begin. We're going to be graphing exponential growth functions. I already gave you the worksheet last class. Let's take a look at it. We did a couple of examples, but just to review what we talked about last time is we're going to be graphing exponential growth functions, and a growth function looks like this, or a growth or decay function. An exponential function looks like this. What makes it an exponential is that you have a variable x as an exponent, okay? I would like everybody to go to these notes right here and actually put parentheses around the b. That way it'll be easier for us to understand. You have y equals a number. It could even be just a negative sign. That would be like a -1 would be your a value if it's a negative sign. And whatever's in here in parentheses, that's what your base is. And that ultimately is considered your growth or your decay factor. In this lesson, we're only doing growth. In Algebra 2, you're going to have something up here either being added or subtracted with the exponent x, but Algebra 1 does not have that. So I'm just going to put like a line through there. Algebra 1 doesn't have that, but in Algebra 2, you will have that. In Algebra 1, we do have a k value out here, and that k value is very important. The k value is a number that's being added or subtracted at the very end, and that tells you your asymptote. And your asymptote, if you don't remember, is the line that your graph will infinitely approach but never actually touch. So right here on this original parent graph that we did, the asymptote is 0 because it doesn't actually have a number that's being added or subtracted at the very end. The k value is 0. So what does that mean? That your asymptote is the equation y equals k, which in this case is y equals 0, which is a horizontal line, which is technically the x-axis. And in this direction, it's infinitely approaching that asymptote, your graph. And again, when we graphed this the last time we met, we did an XY table. We did consecutive integer inputs. That means numbers that are in order, -3, -2, -1, 0, 1, 2, 3. And then we plugged in the number 0, and 2 to the 0, anything to the 0 power is 1. So when you plug in a 0, you get out of 1. And you could plug in a 1, you could plug in a -2, you could plug in a -3. Or if you plugged in 0 and got out of 1, you could make that output, you could make it grow by the growth factor, which in this case is the value b, which in this case is 2. So the output 1 will grow by 2. 1 times 2 is 2. The 2 will grow by 2. 2 times 2 is 4. 4 will grow by 2. 4 times 2 is 8. And that's because the base is 2. If the base would have been 3, it would be 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. If the base would have been like 5, then it would be 1 times 5 is 5. 5 times 5 is 25. You get the idea. And today, we only have values that are greater than 1 in here. Tomorrow, we're going to be talking about exponential decay functions, and right here, you might have a fraction, and it's the same exact concept. Instead of saying 1 times 2, if you have a 1/2 right here, it'd be 1 times half, it would be a half. Then a half times a half would be a fourth, and a fourth times a half would be an eighth. So tomorrow, we'll deal with exponential decay functions where your base is a fraction between 0 and 1, but today, it's just growth functions. Anyway, we also graphed this one. By the way, this guy, if you really want to make sense of it, you should put the 2 in the parentheses. You see, there are no parentheses, so the base is not -2. A lot of people think that the base is -2, but it's not. You technically have your base value of 2, and this negative sign is technically your a value that's out in front of the b. And your a value in this case, when it's a negative sign, that's technically -1. So that's like if you had a -1 times the base 2 to the power of x, okay? So just keep that in mind. Well, we already graphed this last time, and the ones we've graphed did not have a k value. The ones we've graphed did not have a +3 or a -1 out here. So let's get to the ones that actually have a k value. Here's one with the k value -3, okay? So let's begin by graphing this thing as best we can, and to do that, I recommend, yes, identifying your k value, which is ultimately your asymptote. So the k value is -3. So you might as well write down right here, your asymptote is y equals k, which in this case is y equals the -3, okay? Once you identify your asymptote, what I'm going to ask you to do is something weird. I want you to ignore it. So we're going to pretend that it's not there, but we'll deal with it later. So right now, all I'm going to do is focus in on this part of my graph, or this part of my equation, and I'm going to make an XY table for it, an input-output table for it. I'm going to use consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3, right? I'm going to plug in an easy number. Which is the easiest number to plug in, guys? 0 most of the time. So I'll plug in 0. 2 to the 0 is 1. And 1 times the a value of 1/2 is 1/2. So when I plug in a 0, I actually get out 1/2, and that is a coordinate. But keep in mind that this is not a coordinate of our final product, of our final graph. Why not? Because this coordinate belongs to, this coordinate belongs to this guy. And this guy, obviously, we are ignoring that k value of -3. So this is not going to be our final coordinates. We're going to have to shift them later on. But right now, let's find the other coordinates of this original one, ignoring the k. So if your output is 1/2, to get to your next output, yeah, you could plug in a 1 and do all the math, or you could say the output 1/2, let's make it grow, because this is a growth factor of 2. Let's make it grow by 2. So that means 1/2 times 2. 1/2 times 2 is 2 over 2, which becomes 1. And then you could make that output 1 grow also by 2, which would become a 2. And then make that grow by 2 becomes a 4. Make that grow by 2, it becomes an 8 if you wanted to. So you have all these beautiful coordinates to graph, okay? And let's get this straight. If you are multiplying by 2 going this way, because that's a growth factor, multiplying by 2 going this way, 1 times 2 is 2, times 2 is 4, times 2 is 8. Going backwards is not multiplying by 2, it's actually doing the opposite, which is dividing by 2. Another way of saying divided by 2 is multiplying by half. 8 times half, half of 8 is 4. 4 times half, half of 4 is 2. 2 times half, 1. 1 times half is exactly 1/2. 1/2 times 1/2. You could do it on the calculator, but it's pretty easy to do in your head, 1/4. And then 1/4 times half is 1/8. And then 1/8 times half is 1/16. Obviously, you're getting smaller, smaller, smaller. This is half. This is half of the half, 1/4. Half of that is 1/8. Half of that's 1/16. So it keeps getting smaller. So keep in mind that these are points that are not for our final product, for our final graph. These are coordinates for a graph that does not have the k value -3. We're ignoring the k value of -3 right now. So let's plot these points, but they're not our final product, okay? So let's start with 0, 1/2. 0 on the x, halfway up on the y. Put a dot right there, halfway up. And then go to 1, 1. 1, 1 is pretty easy, it's right there. Then let's go to 2, 2. 2 on the x, 2 on the y. Put a dot right there. Then go to 3, 4. 3 on the x, 1, 2, 3, 4, right there on the y. Pretty simple. Moving on to 4, 8. So 4 on the x, 8 on the y. That's 2 units from the edge because this is a 10 by 10 graph. And if you keep going in the negative direction, -1 and only 1/4 of the way up, that's -1 and then half of the half. So that'd be even closer to the x-axis. And then the next one even closer to the x-axis, the next one even closer to the x-axis. So you're drawing dots like if they're actually on the x-axis, but you know it never actually touches the x-axis, it just infinitely approaches. However, this is not our graph. This is the graph of y equals a times b to the x. It's missing the plus k. So in order for us to now include that plus k, in this case, the k value is -3, we're going to have to shift all of these coordinates down 3 units. So the easiest way to shift all these coordinates down 3 units is to start by graphing your asymptote. Okay, so let's graph the asymptote y equals -3. You go to the y-axis, you go to -3, put a dot there, and then from that dot, draw your horizontal line right through it. There's your asymptote y equals -3. Now, why is it great to start with the asymptote y equals -3? Because you know that your graph has to end up there. You know how it ended up right here on the x-axis? It's going to have to end down here. So if you wanted to, you could start by graphing the graph right there on it. But the other points, every single blue point, which is up here, needs to get shifted down 3 units. So this blue point, you would go down 1, 2, 3, and put a dot there. If you have a different colored pen, it might help you out. And then the next one, go down 1, 2, 3, and put a dot there. And the next one, go down 1, 2, 3, put a dot there. And this next one, that go down 1, 2, 3, put a dot there. And this next halfway point, go down 1, 2, 3, put a dot there at the halfway point. And you already know how it's going to behave. The next one's half of the half of that, half of that. At this point, you're just drawing like if it's on the asymptote itself, but you know it never actually touches, just infinitely approaches. So technically, you have two graphs up here. The one you want to represent is the one with the red dots. So let's graph the one with the red dots. So in other words, just draw a line right through those red dots, and you're going to put an arrow on that last red dot because it does go up forever, and it does go to the right forever. Now, what about the other blue dots? You might as well put like 2 X's on them because that's not your actual graph. Does that make sense? So this is the most, I think, the easiest, most precise way of graphing an exponential growth function by hand without any graphing device, okay? So again, I would ignore it and do your consecutive integer inputs, plug in one easy number like 0, get out 1/2, make that output 1/2 grow by 2 times 2 times 2 times 2 times 2, go backwards, dividing by 2, which is the same thing as multiplying by half, times half, times half, times half, times half, times half, times half. You have all your blue points, graph your blue points, then look at your K value telling you that your asymptote's not at the x-axis, it's actually at the y equals -3 because that's your K value of -3. So your asymptote's down there. So you got to shift every single point, 3 units down, 3 units down, 3 units down. You have your final product right here. Let's take a look at another one. This guy right here. Again, we are going to ignore the K value for a little bit. I like to box it in and say I'm going to find some quick inputs and outputs with consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. Let's plug in an easy number. You can plug in any number you want. You don't have to plug in 0. If you wanted to, you could plug in 1. Let me show you that. I'm going to plug in 1 this time instead of 0, even though 0 is probably easier. But if you plug in a 1, 2 to the 1 is just 2, and 2 times 2 is 4. So if you wanted to, you could plug in a 1 and you'll get out a 4. And from there, again, you could just make this output grow by that growth factor of 2. So 4 times 2 is 8, times 2 is 16. And then backwards, if you're multiplying by 2 this way, backwards is dividing by 2, 16 divided by 2, which is the same thing as multiplying by half. 16 times half is 8, times half is 4. What's 4 times half? 2. What's 2 times half? 1. What's 1 times a half? 1/2. What's a half times a half? 1/4. So it keeps getting smaller and smaller as you're going this way. I hope this makes sense to you guys. Let's plot these points. Let's go to the easiest one, 0, 2. Graph that, 0, 2, it's right there. Let's now go to 1, 4, 1, 1, 2, 3, 4, it's right there. Let's go to 2, 8. 2 on the x, 8 on the y, 2 units off of the edge. It's right there. Let's go to -1, +1. It's right there. Let's go to -2 and only halfway up. -2 and only halfway up. That's right there. Then you go to the next one, -3 and then half of the half up. So -3 and then half of the half is even closer to the x-axis right there. So the rest of these dots, you could draw them like they're touching the x-axis, but you know it never actually touches. It just infinitely approaches. Now, why does it look like this is the asymptote? Because if you ignore this, it looks like the asymptote's 0 because the K value is 0 if there's nothing there. But there is something there. There's a +2 right there, which means I need to move every single one of these dots where? Up 2. Yeah, so this blue dot, I'm going to move it up here 2 units to this next red dot. This guy's going to go 2 units up right there. This guy's going to go 2 units up right there. This guy going to go 2 units up right there. This guy at the halfway point, 2 units up to the halfway point, to the halfway point. Put a dot right there at that halfway point. And even before plotting your points, it might be a good idea to graph your asymptote. What is your asymptote? It's y equals the K value 2. So if you went to the y value of 2 and drew a horizontal line right through there, then you know that these red dots are going to infinitely approach it. So you just put dots that are closer and closer and closer till it looks like they're just actually touching that asymptote. So the red dots are your final graph, not the blue dots. If you have different colored pens, I recommend using them, because if it's all the same color, you might get confused. So these blue ones are not it. It's the red dots with that blue graph on that green asymptote. What do you think? Okay, now we are going to have, oh, we haven't even talked about domain, range, y-intercept, and all that other stuff. So the domain, let's go back to the top one. The domain are your x values, and the x values is the x-axis to the left and to the right. So if I asked you, does this graph that we graphed right here, the final graph that we did, does it exist at -10? Yes, it exists right there. Will it exist at -15? Yes, it'll get there. Why? Because it's going in the negative direction forever. How about the positive direction? Will this graph ever get to 10? Well, not on this 10 by 10 graph, but we know that it will keep going up and it'll keep going over. It'll just be way the heck off this graph, right? I mean, if you wanted to, you could plug in the number 10. If you plug in the number 10 up there, 2 to the 10th is a huge number. And then that huge number divided by 2 gets a little smaller, then subtract 3. It's still going to be a big number. So the input 10 gives you the output like, I don't know, 50 something, 60 something, I don't know, right? But anyway, it does go to the left and to the right forever, and the domain are the x values. So where does this graph exist in terms of the x values? It exists to the left forever, it exists to the right forever, so we're gonna say that the domain's x equals all real numbers, and that's the symbol for all real numbers. It's that weird looking R with 2 sticks right there, okay? So again, it goes to the left forever, and it goes to the right forever, even though it goes up. It never goes straight up, it keeps going up and this way, up and this way. So like at 10, it'll just be way the heck up there. At 20, it'll be way up there off this paper, right? So it does go to the left and to the right forever. That's why every single x value is accounted for. It goes to the left and to the right forever. How about the range? The range are your y values. Y is up and down. The y-axis is up here and down there, right? So does this graph that goes up, will it go up forever? Yes, it will, okay? So will this graph ever get to positive 20 up here? Yeah. Positive 50 up here? Yeah, it'll get up there eventually. Will it ever get to -10 on the y-axis? No. Why not? Because as it's coming down, it infinitely approaches the asymptote. It doesn't go below the asymptote. So the range is always going to be either above or below the asymptote, okay? So the range is either going to be above or below the k value technically. So in this case, the graph is above the k value, which is -3, above the asymptote. So how do you say that this graph exists at the y values that are above -3? Y is greater than -3. There's your range, okay? And I don't know, you might want to jot yourself a little bit of notes right here. The range will always be y, and in here you're going to put an inequality, and then your k value, okay? Now, if your graph is visually above the asymptote, it's going to be a greater than. If it's visually below the asymptote, it's going to be a less than, okay? Another way of doing this is knowing how your a value affects it. If you have a positive number that's out here in the front, then it's going to be above. The range is going to be above the k value. But if you have a negative value out here in the front, your range is going to be y is less than the k value. So the a value tells you if it's above or below. You could see that numerically, or if you already have the graph, you could just see it visually that the range is y is greater than -3, okay? What about the y-intercept? Well, the y-intercept, how do you find the y-intercept? You set x equal to 0 and solve. So it's going to be the coordinate 0, comma, and you could see visually right here that y-intercept, where does it cross y-axis? At the location 0, comma, 1, 2, -2.5. So 0, -2.5. That's the y-intercept. And of course, you could actually solve it algebraically. You don't have to graph the whole thing to see it. You could solve it algebraically by plugging in the 0 right there, and 2 to the 0 is 1. 1 times half is a half, and half minus 3 is -2.5, -2.5. So you could solve it algebraically as opposed to seeing the y-intercept visually. Down here, what's the domain? If you haven't figured it out, the domain is always going to be x equals all real numbers. It doesn't matter if it's a growth function, decay function, if it's opening up or down, it's always going to be x equals all real numbers. How about the range? What's the range here? Y is what? Is it above or below the K value, the asymptote? Y is what? Above, because this whole graph is above that green asymptote. So Y is greater than, that means above. What is the asymptote value? It's the K value of 2. So Y is above 2. Y is greater than 2. That's the range. What about the Y-intercept? Well, you could clearly see that the Y-intercept is 0, 1, 2, 3, 4. So the Y-intercept is 0, comma 4, okay? And what is the asymptote itself? It's always Y equals K. In this case, Y equals 2, because you could see up here that the K value is 2. And those are all the things that we're going to have to answer on the next quiz later on this week, okay? You're going to actually have to graph these on quizzes, all right? But on quizzes, it's even easier than doing all this, okay? Why? Because quizzes does a lot of the graphing for you, also known as Wayground, by the way. So let me explain how you would do this question right here on quizzes. Well, you would start by not excluding the K value, including the K value. So are you going to include the whole thing? Whoops, that's ugly. Let me do that again. Include the whole thing. And you start with your asymptote, which is Y equals -3. So you go to Y equals -3, draw your asymptote on quizzes. And then on quizzes, all you need is 2 points. And you're going to find those 2 points with respect to the whole thing. That's why I circled the whole thing in yellow. So on quizzes, you're going to plug in some easy numbers. Like you could plug in 1, you could plug in 2, you could plug in 0, whatever you want. I'm going to plug in 1. If I plug in 1 into here, what's 2 to the 1? That's 2. And what's 2 times half? That's 1, right? Half of 2 is 1. And 1 minus 3 is a -2. So when you plug in a 1, you get out a -2. And that's an actual coordinate. You don't need to shift anything anywhere. That's an actual coordinate. Let's go to the coordinate 1, -2. 1 on the X, -2 on the Y. You end up right there at that yellow dot, okay? Let's plug in 2 now. Plug in 2 right there. 2 squared is 4. 4 times half. Half of 4 is 2. And 2 minus 3 is -1. So when you plug in a 2, you get out a -1. And if you go to that location, 2, -1, you get to that dot right there. So on quizzes, you include the whole thing, plug in 2 easy numbers, you get 2 dots, move your asymptote to where it's supposed to be at, and with those 2 dots and with the asymptote, quizzes or Wayground does the rest. So it's a lot easier to graph on quizzes and Wayground, okay? I hope you guys understand this. Looking at this guy, let's pretend we were graphing this guy on Wayground. So you're going to erase the boxing in part. You're going to include the whole thing. So I'm going to box in the whole thing. You're going to start with the asymptote Y equals 2. So you start by graphing the asymptote Y equals 2. And then all you need is 2 simple points. So you're going to make an XY table, but to the whole thing, including the K value, right? You're going to plug in some easy numbers like 0 and like 1 or like 1 and 2 or whatever you want, whatever works good for you. So if you plug in a 0 in there, 2 to the 0, anything to the 0 is 1. 2 times 1 is 2, and 2 plus 2 is 4. So when you plug in a 0, you get out a 4, and that's an actual point to the entire final graph. So if you went to the location 0, 4 from the origin, 0 on the X, 4 on the Y, you end up at that dot. Let me make it yellow, okay? And then if you plugged in a 1, let's plug in a 1. Plug in a 1 right there. 2 to the 1 is 2. 2 times 2 is 4. 4 plus 2 is 6. So when you plug in a 1, you get out a 6. And if you went to the location 1 and 6, you end up at that red dot right there, which I'm going to do yellow. And with these 2 dots, like on quizzes, there's 2 dots that you could move around. If you move the 2 dots to those precise yellow locations right there and move the asymptote to the Y equals 2 line, then it'll produce the whole perfect graph. So you might be thinking, well, this method looks a lot faster than this method. Yes, that's true. So, but the thing is, it's not 100% precise when it comes to seeing it on the graph on paper. So like if you just graphed this green asymptote and then you started graphing your graph right here and you know that it has to go through these 2 yellow dots, who knows, maybe you end up going like this instead of to the actual point that's up there. I don't know. So that's why we do it the slightly longer way, by ignoring the K value, getting inputs and outputs, plotting those blue dots, and then shifting them according to K so we could get the precise perfect graph. Now on the backside, we have actual assignment, some practice questions. So we already did the first one, which did not have a K value, right? I mean, technically, you could say your K value is 0. That's why your asymptote's at y equals 0. So that one's pretty easy. This one's easy as well because it doesn't have the K value of 0. The other ones do have K values other than 0. So do you guys want to do number 2 or do you want to move on to a different one? If you wanted to do number 2, yes, your K value is 0. So you know your asymptote is going to be y equals 0. So you know your asymptote's going to be right here on the x-axis itself. And you don't have to ignore it because it's 0. So you just go for an xy table with some consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. Plug in an easy number like 0. Look how easy this is. Plug in 0. 3 to the 0 is 1. 1 times 1/3 is 1/3. Okay. Now you could make this output grow by that growth factor of 3. All you got to do is 1/3 times 3. If you don't know, use a calculator. 1/3 times 3, that'll give you a 1. And then 1 times 3 is 3, and 3 times 3 is 9. So you have all these nice points. Let's plot them. 0, 1/3, 0, 1/3, 0, and then only a third of the way up. That's not even halfway up. That's pretty close to the x-axis. Then you go to 1, 1. Then you go to 2, 3. Then you go to 3, 9. So you know it's growing exponentially that way. Going this way, it gets smaller and smaller and smaller, infinitely approaching your asymptote. So you could just draw dots that look like are touching, even though it never actually touches, just infinitely approaches. And there's your perfect graph, guys. 100% perfect without a graphing calculator. Now on Desmos, once again, you just do an XY table, plug in 2 easy numbers, move your asymptote, and it'll graph it perfectly for you. Pick a different one. Any one you want. 6. Looking at number 6. Okay, so the way I want you to do it is to temporarily ignore that K value of -9 and just box in this guy, make a quick XY table for this guy that you're ignoring that K value, do consecutive integer inputs, plug in an easy number like 0, 2 to the 0 is 1, 1 times 3 is 3. What's going to happen over here? I need to multiply this output by that growth factor of 2. So 3 times 2 is 6, times 2 is 12, times 2 is 24. You're not even going to use these last 2 points that are off the 10 by 10 graph, but you could use 0, 3, and you could use 1 and 6. Now, let's keep in mind that going this way, it was growing by 2. 3 times 2 is 6, times 2 times 2. Going backwards, it's dividing by 2, which is the same as multiplying by half. 24 times half is 12. Half of 12 is 6. Half of 6 is 3. What's 3 times half? If you do that on the calculator, that's 3 halves, 3 over 2, which is exactly 1.5, okay? And then if you take 3 halves and multiply it by half to go up, it'll be 3/4. 3/4. You could do that on the calculator. You could do 3 halves times 1/2, and it'll give you 3/4. So we have these coordinates, and if you wanted to keep going up this way, 3/4 times 1 more half would be 3/8, which technically keeps getting smaller and smaller. So let's plot the point 0, 3, which is right there. Let's plot the point 1, 6, which is up here. And let's plot the point 2, 12 is off the graph. But you know what? 2, 12, I'm going to go for it. I want to go 2, 10, 11, 12. I'm 2 units off, but I know it's up here, right? Off the graph. And as I go to the left, -1 on the x, and only 1.5 up. So -1 and then 1.5. So you put a dot right there, that halfway point. And then -2 and 3/4, which is -2, 3/4 of the way up is a little bit more than half. So it's going to be right there, 3/4 of the way up. And then you have -3 and 3/8, that's less than a fourth. I mean, not less than a fourth, that's less than a half. So if you go -3, 3/8 is less than a half. You get the idea that it's going to keep getting smaller and smaller and smaller. So it's going to look like it's touching the x-axis even though it never actually touches. Now, this is not the final product. The final product is actually going back and including that K value of -9. So you're going to have to shift everything down to -9 units. So this end of the graph is going to be down here at the -9 on the asymptote, y equals -9. So here's my asymptote. That's y equals -9. That's the asymptote. And we know that our graph is going to end up down here looking like if it's touching the asymptote. But we need to shift every single one of these blue dots 9 units down. So you're going to take this guy and move it 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And then you're going to take the next one, move it 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. Then you're going to get the next one. By the way, if you wanted to, instead of counting 9 down, you could count, how could you get from this blue dot to that blue dot? It's down 1, 2, 3 over 1. So you could do that here, 1, 2, 3 over 1. And that, wait a minute, and that is the same thing as going 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see? So from here to here, you could say it goes down 1.5 and then 1 over. So you could go down 1.5 and then 1 over at that halfway point. And that's the same thing as taking this guy and moving it down 1, 2, 3, all the way 9 units down. Okay. And we know that it keeps getting smaller and smaller towards the asymptote. So you could just draw your graph going through those red dots. And that's your perfect graph right there. Okay. Now, if we were doing this on Desmos, on Wayground, on quizzes, you do not exclude the K value, you include the whole thing. So include the whole thing, okay? And you start with your asymptote being right here, that green line, okay? And you simply need 2 points. So you make an XY table, including the whole thing, plug in like 0 and 1, and you'll be done. Plug in 0 right there, 2 to the 0 is 1, 1 times 3 is 3, 3 minus 9 is -6. So when you plug in a 0, you get out a -6. And if you actually went to 0, -6, you'll be at that dot. And if you plugged in a 1, what do we get out? Plug in a 1 right there. 2 to the 1 is 2. 2 times 3 is 6. 6 minus 9 is -3. And of course, you could use a calculator to help you out with this arithmetic right here, this math. So if you go to the location 1, -3, you're at that other dot. So on quizzes, with this asymptote, you just move the asymptote down to -9 because that's your K value. And then you plot these 2 points, 0, -6, and 1, -3. And with those 2 points, it'll produce the whole perfect graph for you on quizzes. But right now on paper, you got to go this route. Okay, so let's work on the rest of this for the rest of class. And we will have some type of quiz on this this week.